Hey everyone, welcome back. We're diving into the world of medical research today, specifically how to make it more efficient and, impactful, especially for diseases like TBI and Parkinson's. We'll be looking at a research paper detailing a new framework, something called CWFR, and why it might be a big deal.
Yeah, so when we talk about medical research, right now it often feels a little siloed.
Siloed, okay.
Like imagine scientists working on different pieces of the same puzzle,
Okay.
but they're all in different rooms, can't see the full picture. How frustrating would that be?
Oh, a giant jigsaw puzzle with no box top to guide them.
Yeah.
Yeah, that sounds pretty inefficient.
Exactly. Now imagine giving these scientists a shared blueprint,
Okay.
a common language, if you will,
Uh,
and a way to connect all their findings seamlessly. That's kind of the power behind this new framework we're looking at today. It's called the Canonical Workflow Framework for Research, or CWFR.
CWFR. All right, I have to admit, that sounds a little jargony, but hey, if it holds the key, the faster breakthroughs, new treatments, especially for diseases like TBI and Parkinson's,
Yeah.
I'm all ears. So what's the deal with those diseases? Why has research kind of struggled to make a dent in them?
Well, both TBI, often from impacts to the head, and Parkinson's, a neurodegenerative disorder, they're both incredibly complex.
Yeah.
There's no one-size-fits-all explanation for, what causes them or how they progress. Makes them really tough to study.
It's like trying to solve a mystery with like half the clues missing.
Yeah.
No wonder researchers need a new approach. So tell me more about this CWFR. How does it address all this complexity and maybe find those missing pieces?
Imagine, right, a world where researchers, no matter where they are, what they're specifically looking at,
Okay.
they're collecting and labeling data in a standardized way. They can share their findings seamlessly, build on each other's work, instead of starting from scratch every time. That's the vision behind CWFR.
Okay, so instead of reinventing the wheel every time, researchers can focus on, actually making those discoveries. That's huge. But how do we go from this kind of fragmented research landscape that we have now to this beautiful, symphony of collaboration?
It all starts by, I think, recognizing the common threads that are within the research process itself.
Okay.
So whether you're studying TBI, Parkinson's, any disease really, there are these fundamental steps involved.
Right.
You develop a hypothesis, collect data, analyze it. CWFR provides this standardized framework for these steps. It makes sure everyone's speaking the same language.
A universal language for medical research. Now, that's a really intriguing thought. And you're saying this applies to every stage of the research.
Absolutely. Think of it like a roadmap.
Okay.
Guides researchers from those initial questions all the way to storing and sharing their findings. And, importantly, it makes sure those findings are accessible and understandable to other researchers.
This is starting to sound like a game changer, especially for those battling these complex diseases. But this standardized approach, this roadmap, it's not about, limiting creativity or innovation,
Right.
is it?
Not at all. In fact, it's about fostering a more collaborative environment. Researchers can build upon existing knowledge. They can focus their energy on tackling the big questions.
Okay.
And the key part of that is ensuring everyone's collecting, and this is important, labeling data in a consistent way, a way that's comparable. This is where common data elements, or CDEs, come in. So imagine you're a researcher, right, and you're studying tremors in Parkinson's patients.
Okay.
Without CDEs, you might define tremors differently from a researcher, across the country who's studying the same thing.
So you can't compare apples to apples, or in this case, tremors to tremors. It makes it really hard to see the bigger picture, right?
Yeah, exactly. With CDEs, though, everyone's on the same page.
Okay.
They're measuring and labeling the data consistently, makes it possible to compare those findings across all these different studies.
That's huge. I mean, you could even combine data sets for larger scale analysis, right? Potentially uncovering hidden connections, accelerating the path to new treatments. That's the dream. So how do these CDEs, how do they actually work in practice? What do they look like?
Let's stick with that TBI example.
Okay.
Researchers have actually defined a set of core CDEs that are relevant to all TBI studies.
Okay, so no matter what a researcher is specifically looking at with TBI, they would use these core CDEs.
Exactly. Doesn't matter what their focus is. These core elements cover things like the cause of the injury,
Okay.
the severity, and some basic demographic information about the patient.
Okay, so it's like the foundation of the data set, make sure everyone's capturing the same essential information.
Right. And then you have what are called basic CDEs,
Okay.
which are a bit more specific to certain types of TBI studies. For example, if you're focusing on concussion,
Okay.
there are specific data elements that relate to symptoms,
Makes sense.
duration of loss of consciousness, cognitive function, things like that.
So it's about kind of tailoring that data collection to the specific research question, but still maintaining that common language across all the studies.
You got it. And then, to add another layer of flexibility to it,
Okay.
there are supplemental CDEs.
Look.
And these allow researchers to collect more specialized data.
So if they want to go a little deeper, they can.
Exactly. Could be genetic information,
Okay.
lifestyle factors, even data from brain imaging studies.
It's like building a house.
Yeah.
You have your foundation, your basic framework, and then you can customize it.
Right. I like that analogy. But, just like you wouldn't want to build a house on a shaky foundation.
Of course not.
These CDEs are developed through this rigorous process within the research community.
So it's not just one group deciding what's important.
No. It's scientists, clinicians, data experts. They all come together to determine which data elements are the most relevant, which ones are practical, and most likely to lead to some meaningful insights.
So it's a real team effort.
It is. This ensures that the CDEs are, robust.
Oh.
They reflect the latest scientific understanding
Okay.
and that they can be adopted widely.
Makes sense. It sounds like this paves the way for some really impactful research, but, we're talking about all this data, all this information.
Yeah.
It needs somewhere to live, right?
Yeah.
Some kind of system to manage it all.
Exactly. That's where the biomedical research informatics computing system comes in. BRICS.
BRICS, okay.
Think of BRICS as the engine that powers CWFR, provides the technological muscle to make this vision of standardized and collaborative research a reality.
So CWFR is the blueprint, the common language, and then BRICS is the construction crew that brings it all to life.
I like it. Yeah, that's a great way to put it. BRICS is a really powerful system,
Yeah.
and it's designed to handle that entire research data lifecycle.
Okay.
It includes tools for creating and managing data dictionaries, making sure everyone's using those CDEs consistently.
Okay, so it's like a giant organized database for all of this standardized data. But what about security and privacy? With all this information being shared openly, how do we make sure that patient confidentiality is maintained?
Yeah, no, that's obviously critical.
Yeah.
BRICS has that covered. One of the key components is the Global Unique Identifier System, or GOE.
GOED, okay. What is that?
It's basically a way to de-identify patient data,
Okay.
but you can still track it and analyze it.
Okay.
So instead of using names or other identifying information, each patient's data gets this unique code, protects their privacy, but researchers can still access and analyze all that valuable information.
So it's like each patient's data gets a secret code name to protect their identity, but researchers can still unlock all the important information.
Yeah.
It's really good to know, especially with all this data-driven research happening.
Yeah.
But BRICS is more than just a secure storage system, right? You
Yeah.
said it handles the entire research data lifecycle.
Absolutely. It's got tools for data validation, making sure everything's accurate and consistent. And it has these really powerful query tools so researchers can easily search for specific data across huge data sets.
Okay, so researchers can actually use it to find what they're looking for, even in these massive databases. That makes sense.
Right. And because it's built on those standardized CDEs we talked about, researchers can easily combine and analyze data from multiple studies.
Even if those studies were done by different teams in completely different parts of the world.
Exactly.
Wow, that's a game changer. It's like BRICS is this ultimate research assistant, organizing, analyzing, connecting the dots. You mentioned FAIR data earlier. How does that fit into all of this?
Oh, right. FAIR data is a key principle behind BRICS. It stands for findable, accessible, interoperable, and reusable. Basically, it means research data should be easy to find, access, and use for both people and computers.
So no more data silos, no more research getting lost in the mix. That's really incredible. This all sounds amazing, but I need a real-world example. Where are we seeing CWFR and BRICS making a difference right now?
Okay, well, let's look at the Federal Interagency Traumatic Brain Injury Research System, or FITBEAR.
FITBEAR, all right?
It brings together data from tons of agencies, the Department of Defense, the National Institutes of Health, all working together to advance TBI research.
Okay, so like a team effort on TBI.
Right. By using CWFR and BRICS, FitBear has this centralized hub for all things TBI data. It's way easier for researchers to access and analyze information, work together on studies, and hopefully develop new treatments and prevention strategies faster.
So FitBear is a great example of how CWFR and BRICS can break down those research silos and unify researchers against a specific disease.
Exactly. And we're seeing similar success with the Parkinson's Disease Biomarker Program, or PDBP.
EDBP.
They're using BRICS to collect and analyze data on potential biomarkers for Parkinson.
Biomarkers, so like early warning signs.
Yeah, you could think of them like clues. They're trying to develop more effective diagnostic tools and track the disease's progression more accurately.
So potentially we're talking about diagnosing Parkinson's earlier, figuring out who's at risk, even developing personalized treatments. This CWFR and BRICS duo really seems like it could revolutionize things.
It's definitely got huge potential. And this goes way beyond TBI and Parkinson's, right? What we're seeing is a total shift in how medical research is done.
Yeah, it feels like a new era.
By embracing standardization, collaboration, data sharing, we're opening the door to faster discoveries, more effective treatments, and a healthier world overall.
It's really incredible to see what can be accomplished when researchers work together and speak the same language. This has been a fascinating deep dive into the world of medical research, and a huge thank you to our expert for guiding us through it.
My pleasure. It's been fun.
And to all our listeners, we hope you found this deep dive as interesting as we did. Be sure to check out the show notes if you want to learn more about CWFR, BRICS, and the amazing research happening right now. Until next time, stay curious.